In this lesson, we'll be exploring two main concepts, objects and classes. And by the way, we don't mean trees and pots and rooms full of eager learners. We're clearly talking about objects and classes in JavaScript. In this lesson, we'll be discussing arrays and fundamental data types in JavaScript and in most other programming languages. We'll also spend time looking at the different types of looping statements, and we'll see how to use loops to iterate over the elements of an array. In this lesson, we're going to be exploring the concept of objects and how we can use them, learn how to create and work with objects, and finally unpack classes and experiment with creating them in JavaScript. JavaScript defines an object as an unordered collection of properties. Let's take a look at this a bit closer. So basically in JavaScript, an object is an array of values in no particular order. Each property or method is identified by a name that is mapped to a value. Each property or method is identified by a name that is mapped to a value. The accepted way of creating custom object is to create a new instance of object and add properties and methods to it. Here's a quick example for you. This example creates an object called person that has three properties, name, age, and job, and one method, sayName. The sayName method displays the value of this .name, which resolves to person.name. Early JavaScript developers used this pattern frequently to create new objects. A few years later, object literals became the preferred pattern of creating such objects. The example that we just looked at can be written using object literal notation, like this. The person object in this example is equivalent to the person object in the prior example, all with the same properties and methods. These properties are all created with certain characteristics that define their behavior in JavaScript. We're now going to have a look at the properties in JavaScript. As W3 School said, properties are the values associated with a JavaScript object. The characteristics of properties are described using internal attributes. These attributes are defined by the specification for implementation in JavaScript engines, and as such are not directly accessible in JavaScript. To indicate that an attribute is internal, you would surround the attribute name with two pairs of square brackets. Data properties. Data properties contain a single location for a data value. Values read from and are written to this location. Data properties have four attributes describing their behavior. So let's have a look at those attributes, starting with configurable. Configurable indicates if the property may be redefined by removing the property via delete, changing the property's attributes, or changing the property into an accessor property. By default, this is true for all properties defined directly on an object, as in this first example repeated here. Enumerable. Now, enumerable indicates if the property will be returned in a for-in loop. By default, this is true for all properties defined directly on an object, as in this example. Writable. Writable indicates if the property's value can be changed. By default, this is true for all properties defined directly on an object, as in this example. And for our final attribute, we're going to take a look at value. Value contains the actual data value for the property. This is the location from which the property's value is read, and the location to which new values are saved. The default value for this attribute is undefined. When property is explicitly added to an object, configurable, enumerable, and writable are set to true, while the value attribute is set to the assigned value, as shown in this example. Here, the property called name is created, and a value of Nicholas is assigned. That means value is set to Nicholas, and any changes to that value are stored in this location. Let's take a look at the object-defined property method of changing any default property attributes. This method accepts three arguments: the object on which the property should be added or modified, the name of the property, and the descriptor object. Let's take a look at the object-defined property method of changing any default property attributes. This method accepts three arguments: the object on which the property should be added or modified, the name of the property, and the descriptor object. The properties on the descriptor object should match the attribute names. This is configurable, enumerable, writable, and value. You can set one or all of these values to change the corresponding attribute values. As shown in this example, it creates a property called name with the value of Nicholas, that is, read only. The value of this property cannot be changed, and any attempts to assign a new value are ignored. We're now going to be moving on to enhanced object syntax. ECMA Script 6 introduced a handful of extremely useful syntactical tools for defining and interacting with objects. None of them meaningfully change existing engine behavior, but they enormously enhance the convenience of dealing with objects. Let's take a look at two of them. The property value shorthand convention. Developers frequently find that when adding a variable to an object, the property name used to key a variable often matches the variable name itself. An example. The property value shorthand convention was introduced to allow you to simply use the variable itself without the colon notation, and the interpreter will automatically use the variable name as the property key. If the variable name is not found, a reference error will be thrown. Now, before we move forward, here's a code that's equivalent. And then we have the function properties shorthand convention. With computed properties, the property assignment can occur inside the object literal's initial definition. Square brackets around the object property key instruct the runtime to evaluate its contents as a JavaScript expression instead of a string, like in this example. When defining function properties of an object, the format almost always takes the form of a property key referencing an anonymous function expression, as follows. The new shorthand method syntax follows this pattern and allows the developer to give up the capability to name the function expression, which most of the time is not useful anyway, and in exchange dramatically shortens how a function property can be expressed. From a behavior standpoint, the following example is identical to the previous code. ECMA 6 also introduced object destructing. Object destructing allows you to perform one or many operations using nested data within a single statement. With respect to objects, this gives you the ability to perform assignments from object properties using syntax that matches the structure of an object. Now, here's an example of two equivalent code snippets, the first one without object destructing, and then the second using object destructing. So here's the first, an example without object destructing. And the second, an example using object destructing. Destructing allows you to declare multiple variables and simultaneously perform multiple assignments, all inside single object syntax. If you want to reuse the property name as a local variable, you can use a shorthand syntax like this. We're now going to talk about identifying objects and deleting objects. Just as properties can be added or updated to objects at any time, they can also be removed. There are two ways to identify an object, using a dot or square bracket. The following two JavaScript expressions have the same value. The first syntax, using the dot as an identifier, and the second syntax, using square brackets and a string, looks like array access, but to an array indexed by string rather than numbers. When you access a property of an object with the square brackets array notation, the name of the property is expressed as a string. Strings are JavaScript data types, so they can be manipulated and created whilst a program is running. So for example, you can write the following code in JavaScript. This code reads and concatenates the address 0, address 1, address 2, and address 3 properties of the customer object. This brief example demonstrates the flexibility of using an array notation to access properties of an object with string expressions. Please note that this code could be rewritten using the dot notation. Did you know, in computer programming, the word concatenate refers to joining character strings end to end. For example, the concatenation of snow and ball is snowball. Alright, let's have a quick look at deleting properties. The delete operator removes a property from an object. Its single operand should be a property access expression. Surprisingly, delete does not operate on the value of the property, but on the property itself. An example. Okay, well, we have set a fun challenge for you to tackle after this lesson. Your task will be to write the JavaScript object named customer. Then create the properties first underscore name, last underscore name, and phone. And then assign these properties any value of your choice. This is our last section for this class, before we dive into our demo. Now, classes are a pretty new syntactical construct in ECMA script. They are basically a template for creating objects that use prototype and constructor concepts. Similar to the function type, there are two primary ways of defining a class: class declarations and class expressions. Both use the class keyword and curly brackets. Class declaration. For class declaration, you simply write class, then class name, which is person in this case, and then empty brackets. Like this. Class expression. Just like functions, class expression can be defined inside another expression. In this example, we assign class to a variable named animal. Moving on swiftly, let's take a look at the class constructor. The constructor keyword is used inside the class definition block to signal the definition of the class's constructor function. Using the method name constructor will signal to the interpreter that this particular function should be invoked to create a fresh instance using the new operator. Definition of the constructor is optional. Electing not to define the class constructor is the same as defining the constructor as an empty function. Let's have a look at the class constructor in action. Instantiating a person using the new operator operates identically to using new with a function operator. The only perceptible difference is that the JavaScript interpreter understands that using new with a class means the constructor function should be used for instantiation. By the way, instantiating means calling a constructor of a class which creates as an instance or object of the type of that class. Calling a class constructor using new will do the following. A new object is created in memory. The new object's internal prototype pointer is assigned to be the constructor's prototype property. The this value of the constructor is assigned to the new object. The code inside the constructor is executed, adds properties to the new object. If the constructor function returns an object, that object is returned. Otherwise, the new object that was just created is returned. In this example, we created three classes: animal, person, and vegetable. And now we instantiated instance for each of them using the new operator. Here's an example of a constructor that initializes three fields. Class constructor example 2. With the new instance field of syntax of the new JavaScript that is likely to be standardized, you could rather write this. The field initialization code has moved out of the constructor and now appears directly in the class body. That code is still run as a part of the constructor, of course. If you do not define a constructor, the fields are initialized as a part of the implicitly created constructor. The this dot prefix that appeared on the left-hand side of the assignment are gone. But note, you still need to use the this dot prefix, even on the right-hand side of the initializer's assignments. The advantage of initializing your instance fields in this way is that the syntax allows, but does not require, you to put the initializers at the top of the class definition, making it clear to the readers exactly what fields will hold the state of each instance. So we thought to include a demonstration to take you through some of the steps we've just covered, like how objects can be created and how to remove properties from an object. And we will also talk you through all the keys of an object. Now, let's see all of these in action. As we know from the lesson data types, there are 7 data types in JavaScript. 6 of them are called primitive because their values contain only a single thing. It could be a string or a number or whatever. In contrast, objects are used to store key collections of various data and more complex entities. In JavaScript, objects penetrate almost every aspect of the language, so we must understand them first before going into depth anywhere else. So an empty object can be created with one of the 2 syntax. The first one is called object construction. What we can do is we can simply type let user equal new object and empty parentheses. And now we've just created a user using the construction syntax. The second one is called object literal. And for this one, we can simply type let user equal and empty curly brackets. There we go. And so these are the 2 different methods of creating an object in JavaScript, and usually the second figure brackets are used. We can immediately put some properties into the curly brackets as a key and value pairs. Alright, so let's create the user object with 2 properties. We simply type let user equal and then pass 2 properties, name and age. So I can give John the value and then the age of 30. The first property has the name, and the value, John. The second one has the name, age, and the value of 30. So when we save this, we can access the property value of any object using 2 methods. The first one is called dot notation. Alright, for example, if I want to print John to the console, I could write console.log user.name. And now when I save this and go to the console, I will find John rendered to the screen. I can do the same thing with age. I could write console.log of age. So let's do that, console.log user age, and if I save this, I will find 30 rendered after the name of John. The value can be of any type. Let's add a Boolean one and give the user an admin permission. So let's comment this out. And then we can write user.isAdmin and give it a value of true. By doing this, we've just added a Boolean type to the user object, and now I can console.log isAdmin and then save this and go back to the console. I will find true rendered to the screen. Alright, so now we've just seen how to add a property to the object. Let's see how we can delete a property from any object. If you want to delete the age property from user object, we simply type delete. And then user.age. And when I save this, and again console.log, user age, user age, and then save this, I will find undefined value because the age property is no longer a part of the user object. We can also use multi-word property names, but then this property should be quoted in a single or double quotes. Let's just delete all of this quickly, and then see how we can add a property to the user object. So, if you want to add a new property saying that or checking if the user likes birds or if they don't like birds, you can add property in double quotes and then type likes birds and give it a value of true. True. And then when I try to console.log user likes birds, I will get an error, as you'll see. Yep, error. It's a syntax error, saying missing after argument list. And why is that? Well, it's because dot notation doesn't work with a multi-word property name. So to solve this problem, we can use the bracket notation. Now, how the bracket notation works is if I type console.log user of likes birds, likes birds. Let's comment this one. And when I save this, I should see true render to the screen saying that this user likes birds. Now, to delete any properties of multi-words, we do the same thing. We write delete user of likes birds. Let me show you. Delete user of likes birds. If we put this after the delete method and save the file, we will get undefined. Again, because the file name or the property name of likes birds is no longer a part of the user object. You see, undefined. Now let's see how we can walk over all keys of an object by using a special form of a loop called for in. It's completely different from the for loop that we studied in the previous lessons. For instance, if you want to iterate through the values of this object, user object, we can simply type for let key in user. And then open up our for block. And here I want to consult each key of user object. So I will write console.log of key, console.log of key. And now if I save this and go back to the console, I will see name, age, likes birds, properties, rendered to the screen. Name, age, likes birds, there we go. Now, instead of printing the properties, I want to print the properties value. So let's just comment this. Let's comment this. And console.log user of key. And when I save the file, I should get John 30 and likes birds rendered to the screen. Let's check it out. There it is, John 30, true. As we expected. Another feature of objects that we can see is declaring the object using const rather than let operator. So let's take all of this out and declare our new user object using the const operator. We simply const user equal. Then we have name property of John. An object declared as a const can be changed. So for instance, if I add another property to this object, as we did before, user.age equals 25. 25. And when I save this and console log user.age, user.age, and then save the file, I will find 25 on the screen. Until now, we assume that all properties of user are primitive, but properties can be referencing to other objects. So what can we do in this case? Well, let's delete our age over here and imagine that the user object, we have another property. Let's just delete this quick. All right, so the user object, and we have another property as that user object. Let's call it sizes. And sizes is a property, and it's an object. So in the sizes, we have two properties. The first one is height, and that's 185. And the other is width, and that's 50. So height, 185. Width is 50. And now, when I save this and I want to console the height of John, I simply type console log user.sizes .height. User.sizes .height. And when I save this, I should get 185 rendered to the screen. And here we just used an object inside other objects. Now, let's have an example of function. So we can add function as a property inside an object. And we do that by simply adding a new property to the user object. And we can say this function is called sayHi. And to declare this function, I could say sayHi function, then parentheses, and open the curly brackets and say console.log of hello there. In a double quotation, and don't forget that, the double quotation. Then instead of console log user.height, we can just call the function by typing user.our property name, sayHi function, and then save this, and we should get hello there rendered to the screen, just as we expected. There it is, hello there. Now, there is a shorter way of using or declaring function in an object. So instead of writing functions like this, we can omit the function word, and we can just type sayHi and parentheses and write our function body like that. Let me show you. And when I save it, I get the same result, saying that hello there is in the screen. So omitting the function is just giving a shorter way and a cleaner code that most of the developers can follow these days. It's common that an object method needs to access the information stored in the object to do its job. For instance, the code inside user.sayHi may need the name of the user to access that property. And for accessing the object, a method that we can use is the this keyword. So the value of this is the object before dot. So to understand this, let's give an example. So now we'd like to print the John value through the sayHi method. So instead of console.log hello there, let's use the this keyword, which refers to the user object. So this here means user objects. So we can type this, the keyword this, dot name, Now we would like to print the property or the value of the name property through the sayHi property or the sayHi function. When I save this, instead of getting hello there, I will get John rendered to the screen. And there we go, there's John. And technically, it's also possible to access the object without this keyword by referring it via the outer variable. Let me show you what I mean. So over here, what we can do is if we take this and change it with user, and then save the file, we should get the same result of John. There we go, John. So it's just a shorter way of doing that. And yeah, well, that's it for this tutorial. I hope you enjoyed it, and I will see you very soon, everyone. Thank you.